Our next thing we're going to study is parallel circuits. A parallel circuit is a circuit which has multiple paths. So it might look like this. You can see why it's called a parallel circuit, because the resistors are in parallel to one another in this picture. It might look slightly different. It might look like this. But in either case, there's multiple paths for the electrons to follow. The current that comes out of the battery I total then splits, and some of it goes through one of the resistors, and then some goes through another resistor. So if you look at this point right here, this junction, we have I total going into it and I1 and I2 going out. If I had a third resistor, I'd have I3 going out. So the rule is going to be based on our junction rule, that I total going in has to equal I1 plus I2 plus how many other currents there are. For the voltages, though, if I do my loop rule, if I go around this left-hand loop, you'll notice that the voltage I gain in the battery, I only go through the left-hand resistor. So all of the voltage I gain in the battery, I have to lose in that first resistor. So V total has to equal V1, the voltage for the first resistor. And then also, if I do the outside loop, whatever I gain in the battery, I'm going to lose in the right-hand resistor. That's the only resistor I go through. So the electrons are going to only go through one resistor. Some of them are going to go through resistor 1, some are going to go through resistor 2, but they have to lose all their voltage in that one resistor that they go through. So V total equals V1 equals V2. So the voltages are the same. So it's the reverse of series circuits. In series circuits, the voltage is added and the currents were the same. In these parallel circuits, the currents add and the voltages are the same. The resistance rule is a little more complicated. It's 1 over R total equals 1 over R1 plus 1 over R2. Okay, plus whatever. So it's a reciprocal rule. So for this example that we have, we're going to find the equivalent resistance, potential difference in power for each element in the circuit below. So we're going to draw the same type of chart. It's almost exactly this, or it is exactly the same. It's just that the rules are going to be different. So when we fill it out, it's going to look a little different. So we have V, I, R, and P, and total 1 and 2. So our givens in this particular problem are R1 is 5, R2 is 10, and V is 30. Now these tend to be easy if you're given the voltage, because for parallel circuits, the voltages are the same. So I can fill in that this voltage is going to be 30, and this voltage is going to be 30. Then I can do V equals IR to get the currents. So if I think of V equals IR, I is going to be V over R. So for resistor 1, it's going to be 30 divided by 5 is 6. And for resistor 2, 30 divided by 10 is 3. Now the currents are going to add. So I total is just going to be 6 plus 3 is 9. Now to get this R here, there's two ways to do it. I'm going to do it both ways, just so you can see that the easier way for this particular problem is to do V equals IR. So 30 equals 9R. So R is 30 over 9, which is going to be 3.3 repeating. Now the other way is we can use that resistance rule, and I want you to see how this works as well. So I would do 1 over R total equals 1 over R1 plus 1 over R2 is 1/5 plus 1/10. My common denominator for this would be 10, so I can change this to 2/10 plus 1/10, which is equal to 3/10. Now I'm not done because that's 1 over R total. So to get R total, I have to take the reciprocal. So R total is going to be 10 over 3. And 10 over 3 is also 3.3 repeating, just like we got when we did it using V equals IR over here. Now our last step is going to be to get the power. For power, I do P equals VI. So 30 times 9 is 270. 30 times 6 is 180. And 30 times 3 is 90. And the powers are always going to add up. So 90 plus 180 does equal 270. So a second example is this one here. I'm going to draw my chart. And I'm not going to bother with power in this one because I wasn't asking for power. I'll do VIR down the side and total 1 and 2. Okay. So my total voltage is 40. That was given. I was given that the resistor, the second resistor here is 10. And then it says the ammeter reads 8 amps. And that's reading I1 because I total comes out of the battery and goes this way. And then it splits into I2 and I1. So the ammeter's in this branch, so it's going to be I1. So that's going to be 8. This one seems kind of tricky because they're all in different rows and columns, but remember the voltage for a parallel circuit is the same. So this voltage is going to be 40, and this voltage is going to be 40. V equals I times R, so 10 times I is going to give me 40, so this one has to be 4. 40 divided by 8 would give me R, so this is going to be 5. And then 8 plus 4, because the currents add, is going to give me a total over here of 12. And then to finish this off, I could do R equals V over I. So it's 40 over 12, which is 3.3. And we just did the same problem actually up above. If I have 5 and 10 and do the 1 over rule, I end up with a total resistance of 3.3 repeating.